If you are here, I will expect that you have studied extensively my first presentation on stoichiometry. If not, it is very important to start with that. Otherwise, the discussion here will be difficult for you to comprehend. So the key words to take note of: molar mass, that's talking about the mass from 1 mole of a particular substance, usually a compound or maybe a molecule. By the time you add up all the mass of the atoms you have in that 1 mole of a substance, then you're going to have your molar mass. For molar volume, that is the volume that 1 mole of a gas occupy under condition of standard temperature and pressure, and the value is a constant, which is 22.4 dm cube. Also, don't forget that 1 mole of a substance is equivalent to Avogadro's number of particles. The value is 6.02 times 10 to the power 23. So we are talking about 2 moles of a particular gas, then you multiply this Avogadro's number by 2, and on like that. Then for molar mass, which is the mass for 1 mole of a substance, so by the time you add up the masses together, you get the molar mass. So 1 mole of a gas is also equivalent to the molar mass of that particular compound. Then amount N can be expressed in about 3 ways. Amount can be equal to mass over molar mass. It can also be equal to volume over molar volume, and amount can be also equal to C, which is molar concentration multiplied by the volume. This concentration N must be molar concentration, which is mole per dm cube. Mole per dm cube, and the volume, because of that, you must have it to be in dm cube, not centimeter cube. By the time you multiply mole per dm cube and dm cube together, you are going to have mole as the final unit, which is the unit for moles, or the amount. Then finally, don't forget the expression that connects mass concentration with molar concentration and molar mass. The mass concentration will be equal to molar concentration multiplied by molar mass. Don't forget, the unit for mass concentration is gram per dm cube. When you are given a stoichiometric calculation, it is very important that you break it down in steps. Otherwise, you get confusing between and you get muddled up. So break it down into bits. What weight of sodium hydroxide is required to make 500 centimeter cube of 0.2 molar solution? Another thing which is very important about stoichiometry is you perfecting writing the formula of your compound. If you are yet to master that, it's important you start with that. In this case, you are given sodium hydroxide. The formula of that compound is not given. You should know that sodium hydroxide is NaOH. So we are asked, what is the weight? The weight being talked about here is more like talking about the mass. So we are looking for the mass M of sodium hydroxide. We don't know. Required to make 500 centimeter cube. That is volume. Volume V equal to 500 centimeter cube of 0.2 molar. This capital M also means mole per dm cube, which is the unit for molar concentration. So it's either is written as 0.2 molar with capital M, or it is written as 0.2 mole per dm cube. Either way, you know that it's talking about molar concentration. So we have 0.2 molar. So how do we go about this? We're giving volume, we're giving concentration. Anytime the question is talking about only a compound, one of the formula that is always very applicable is when you have N equals to CV. In this case, your C is your molar concentration, which is given, and V is your volume, which is also given. So from there, we can get our amount, which is N, from which we can get our mass. So from N equals to CV, we know our C to be 0.2 molar, and our V is 500 centimeter cube. But don't forget, if our C is mole per dm cube, our volume must also be in dm cube. So we have to convert this volume to dm cube. And by doing that, we have to divide our value by 1000. So 500 divided by 1000 will give us 0.5 dm cube. So from there, our N will be equal to 0.2 multiplied by 0.5, and that will give us 0.1 moles. Now that we have gotten our amount in moles, we are actually looking for the mass. So we can just go about and use the formula N equals to mass, which is what we are looking for, over molar mass. So the amount N, we already know that we're looking for the mass. So that means we have to calculate the molar mass of that particular compound. So to know the molar mass of sodium hydroxide, don't forget that will mean we add up the mass of each atom you have there. So sodium is 23, and we have just one of it, plus one oxygen atom, which is 16, plus one hydrogen atom, which is 1. So by the time we add this together, we are going to have 40 gram per mole. That's the molar mass of sodium hydroxide. So from there now, you can come back to this expression and say our mass, which is now going to be equal to N times molar mass. That's the amount times molar mass, and that will give us 0.1, our N, multiplied by 40, which is our molar mass. So from there now, our value will be equal to 4.0 grams. It's going to be grams because we're looking for the mass of that particular compound. This question says, how many grams of H2SO4? So we're looking for the mass of H2SO4 as M of H2SO4 is what we're looking for, that are necessary for the preparation of 0.175 dm cube. So we've been given volume already in dm cube, which is 0.175 dm cube of 6.0 molar. That's our molar concentration. So that's our C equals to 6.0 molar. We're looking for the mass just like the previous question. You can just start by saying N equals to CV. Our C will be equals to 6.0 multiplied by the volume, which is already given in dm cube, will not have to be converted again. That will be multiplied by 0.175, and from there the amount will be equal to 1.05 moles. But we're looking for the mass. So from the expression N equals to mass over molar mass, we already know our N, which is the amount. We're looking for the mass. Now we can calculate the molar mass of the compound. The compound in question is H2SO4. So molar mass of H2SO4, that will be equals to, the atom of hydrogen is already given to be 1, so that will be 1 multiplied by 2 because we have 2 atoms of hydrogen there, plus an atom of sulfur, that will be 1 multiplied by 32, plus 4 atoms of oxygen, that will be 4 multiplied by 16, and that will give us 2 plus 32 plus 16 times 4 should give us 64. Okay, and when you add this together, you are going to have 98 gram per mole as the molar mass of H2SO4. So from this expression now, we can say our mass will be equal to, when you cross multiply, that will be N times molar mass, and so the mass will be equal to, the N is 1.05 times 98, and that will give us 102.9 grams, which is approximately 103 grams of H2SO4. So at this point, you should be able to solve this question. So you can pause this video at this point and try to solve your own before you compare your answer with what I'll be producing here. So here the question says, if 0.20 mole per dm cube, this is the concentration of sodium hydroxide, was evaporated to yield 5.0 gram, that's the mass of the same sodium hydroxide, not molar mass, just the mass. Calculate the volume of that sodium hydroxide. So we're looking for V. And don't forget, once you are given The atomic mass is here. That's already telling you that what you can easily get your molar mass. So if we are looking for the volume, let's start from saying N equals to CV, because we're talking about just one compound there, sodium hydroxide. So that should always come to your mind, N equals to CV. Then you can work around that. So if that is it, we know our C already. The V is what we're looking for. The N, we're not given the N directly. So how do we get the N? You can easily get the N by saying N equals to mass over molar mass. Yes, the mass is given. The molar mass we can easily calculate out. So molar mass of the compound, sodium hydroxide, that will be equal to 23 of sodium plus 16 of oxygen plus 1 of hydrogen. That should give us 40 grams per mole. So from there now we can see that our N equals to, the mass is 5 grams, that's 5.0 over 40, and that will give us 0.125 moles. Okay, that's the amount. From there, you can now return back to this our expression. We now got the N. We're given the C in the question already. It is the V we're looking for. So if you write this expression, your V equals to N over C. So your V will be equals to, the N is 0.125 over the C, which is 0.20. And from there, the volume will be 0.625 dm3. It's going to be dm3 because this amount here, that's moles, and this volume, this concentration here is mole per dm3. So if you express this mole over mole per dm3, the mole cancel the mole, and what you're going to be having is going to be what? dm3. So the volume here is in dm3, but the options given to us are in centimeter cube. So we convert that dm3 to centimeter cube. Don't forget, 1000 centimeter cube equals to 1 dm cube. So to convert 0.625 dm cube to centimeter cube, you multiply by 1000, and that will give us 625 centimeter cube. How many moles of hydrogen ion, that's what you're looking for, are there in 1 dm cube of 0.5 molar H2SO4? This volume and this concentration given are for H2SO4, from which you want to get the number of moles of hydrogen ion. So for the H2SO4, we're given the volume to be equal to 1 dm cube, and we're given the concentration C to be equal to 0.5 molar. So from there we can say N equals to CV, and that will give us 0.5 times 1, and that will give us 0.5 moles of H2SO4. But the question is asking us how many moles of hydrogen ion from H2SO4. Remember, H2SO4 will give us hydrogen ion. When it ionizes, you are going to have 2 hydrogen ion coming from 1 mole of H2SO4, such that you have something like this. 2 hydrogen ion is coming out, then the SO4 2 minus. So the question is about how many mole of hydrogen ion is produced from this mole of H2SO4. So if that is the case, from this particular equation, we know that 1 mole of H2SO4 will give us 2 moles of hydrogen ion, right? So now for the 0.5 moles of H2SO4 we have gotten here, for the 0.5 moles of H2SO4, what will now be the corresponding mole of hydrogen ion? You can simply cross multiply at this point, and you have that to give you 1 multiplied by x will give you 0.5 times 2, and then your x will be equal to 0.5 times 2 over 1, and that will give us 1 mole of hydrogen ion. That is the answer. Here the question says the mass of 800 centimeter cube of an unknown gas Q at SCP is 1 gram. So this is the mass, and you are given the volume. What is the molar mass of Q? You cannot start by saying N equals to CV because C is not given and neither were you given N. So this expression will not work. Let's see, can you say N equals to mass over molar mass? The question says you calculate the molar mass. Yes, we are given the mass, but N is not given. So this formula cannot work yet. But we are given volume also. So what formula can we use that has to do with volume? You can say N equals to volume over molar volume. Molar volume, don't forget, is a constant. That's what we are given here. That's gas molar volume equals to 22.4 dmq. So if that is the case, we can get our N first, from where we can go ahead to obtain the molar mass of that Q. So now, from N equals to V over molar volume, N will be equal to, don't forget, your molar volume is in mole dm³ per mole. So this volume also must be in dm³. So if your volume has been given to you in centimeter cube, it's not expected that you convert that your volume from centimeter cube, which is 800, divided by 1000. That will give you 0.8 dm³. That's the volume. So applying that in this expression now, so our N will be equals to 0.8 over the molar volume, which is 22.4. So from there, our N will be equals to 0.0357 moles. So now that we have gotten the moles and we are looking for the molar mass, this expression now can be applicable. So from there, looking for the molar mass, N equals to mass over molar mass. So if we make the molar mass the subject of the formula and you rewrite that expression, your molar mass be equals to mass over N. And that will now give you the mass given to us is 1.0 over the N now, which is the amount, that will be 0.0357. So from there, the molar mass of Q will be equals to 28. Don't forget, molar mass, the unit is the mass for 1 mole. So that will be gram per mole. And that is it. This question says a gaseous mixture contains this mass of hydrogen and this mass of oxygen. You now have to find the mole ratio of hydrogen to oxygen in the mixture. So what we're looking for is the mole ratio, means the mole of hydrogen ratio the mole of oxygen. That's what we're looking for. And don't forget, hydrogen and oxygen, they are diatomic gases. So you have to be very careful and cognizant of that fact. Other diatomic gases that we have, always remember this acronym on halogens. These elements, hydrogen, oxygen, nitrogen, as well as all the halogens, are diatomic. What are the halogens? Those elements that ends with INE, like fluorine, F2, chlorine, bromine, iodine. These elements are diatomic. So coming back to the question, we're looking for the mole ratio of hydrogen to oxygen. What we're given is the mass. The mass of hydrogen given to us is 0.256, and the mass of oxygen is 2.0 grams. So the mole is the same thing as amount. Don't forget, amount equals to mass over molar mass. So if that is the case, we are given the mass already, we can find the molar mass of each of those gases. Hydrogen is H2, so the molar mass will be 1 multiplied by 2. Since the atomic mass of hydrogen is 1 and we have 2 atoms there, so the molar mass of hydrogen gas will be 2 grams, or the mass. Then the oxygen, O2, that will be, an atom of oxygen is 16, and you have 2 atoms there, so that will be 2 multiplied by 16, and that will give you 32 grams. So with this now, grams per mole, that's the molar mass per mole. So now with this, the amount N for hydrogen will be equal to the mass over molar mass, that will be 0.256 over the molar mass is 2 ratio the mole of the oxygen, that will be the mass over molar mass also, that will be 2.0 grams over the molar mass is 32. So when we do this, the amount for hydrogen will give us 0.128 ratio. The amount for oxygen will be 0.0625. So to get the mole ratio, we divide by the lower number. So between these two numbers we have 0.0625 is lower than 0.128. So we divide both sides by the lower number. So divide by 0.0625 divided by 0.0625. So if you do that, this will give us a 1, and this one will give us 2.05, which is approximately 2:1, and that is the mole ratio of hydrogen to oxygen in that question. This question says how many moles of oxygen would contain this number of molecules. So the question is about how many moles, that's moles and number of molecules of the same gas, which is oxygen. So it's mole and number of molecule relationship we have in there. So how many moles of oxygen, say X moles of oxygen, would contain 1.204 times 10 to the power 24 molecules of oxygen. Okay, so having gotten this, you can go back to your standard, which is very essential that you know that 1 mole of any gas will have the Avogadro's number of molecules. So with that now, you can see that 1 mole of oxygen, okay, which is also a gas, like any other gas, will have the Avogadro's number of molecules. That will be 6.02 times 10 to the power 23. That's the value given to you here, molecules of oxygen. So with that, you can simply cross multiply, and you have X multiplying 6.02 times 10 to the power 23 equals to 1 times 2 1.204 times 10 to the power 24. So with that, your S will be 1.204 times 10 to the power 24 over 6.02 times 10 to the power 23. And when you do that, your X should give you 2 moles. So 2 moles of oxygen would contain 1.204 times 10 to the power 24 molecules of that particular gas. This question says the number of oxygen molecules that is present in 16 grams of the gas is what? Actually, we can approach this question from 2 perspectives. Yes. So the first one is, instead of using the gram directly in that question, we can make use of the moles. We can convert that mass to mole, knowing that N equals to mass over molar mass. So the mass is 16. The molar mass, don't forget, we are talking about the molecule of oxygen, and the molecule of oxygen is O2. So the molar mass of oxygen will be 16 multiplied by 2, and that will give us 32. So 16 divided by 32, our N will be equal to 0.5 moles. So now we'll be making use of 0.5 moles instead of 16 grams in that question. So the question is the number of oxygen molecules. So X molecules of oxygen, okay, that's present in, instead of 16 grams now, in 0.5 moles of oxygen. With this, we can go back to the standard value and say, since we know that for 1 mole of any gas, the number of molecules will be equal to the Avogadro's number. So for 1 mole, so we write 1 mole under the one that has to do with mole A. So that means 1 mole of oxygen now has Avogadro's number of molecules. So we come under the molecules and we write 6.02 times 10 to the power 23 molecules. So with this, we can cross multiply, and then from there, our x multiplied by 1 will give us 0.5 multiplied by 6.02 times 10 to the power 23. And from there, our x, which is the number of molecules of oxygen, will give us 3.01 times 10 to the power 23 molecules of oxygen. This is one approach. The second approach is knowing that 1 mole of any substance will be equal to the molar mass of that substance. And of course, 1 mole of any substance is also equal to the Avogadro's number. So if that is the case, that means 1 mole of oxygen, because to the molar mass of oxygen, we say it is O2, so that molar mass will be 16 times 2, and that will be 32. So 1 mole of oxygen equal to 32 grams per mole, which can be related to the mass as 32 grams. And it's also equal to the Avogadro's number, which is 6.02 times 10 to the power 23 molecules. So since the question is asking us about the number of oxygen molecules and we are given the mass, so we can relate this in that question. So saying that 32 grams of oxygen is equals will give us 6.02 times 10 to the power 23 molecules of that gas. So now we are now looking for the number of molecules. So X molecules of oxygen, okay, will be present in 16 grams of that gas. So in 16 grams of oxygen, what is the number of molecules? So at this point, we cross multiply, and that will give us 32 times X equals 16 multiplied by 6.02 times 10 to the power 23, and your X will be 16 times 6.02 times 10 to the power 23 divided by 32. Your answer should still be 3.01 times 10 to the power 23 molecules. And that is it. This question, you are given an equation, and it said, using that equation, what volume of carbon dioxide? The volume of carbon dioxide, this is carbon dioxide. So you are looking for its volume. That's liberated when 53 grams of sodium carbonate. This is sodium carbonate, 53 grams of it is dissolved in hydrochloric acid. Now the question is about the mass of sodium carbonate that is producing what volume of carbon dioxide. So that's a mass volume relationship. Mass of Na2CO3 with respect to the volume of CO2. Now from the question, we're given 53 grams of sodium carbonate. So 53 grams of Na2CO3. We are asked what volume of CO2 is produced from that. X volume of CO2. Once you have done this, you have just interpreted the question. So you now go back to the equation and figure out what is the mass. Now this one is talking about mass. So you go back to that equation and figure out what is the mass of this compound itself in that equation. That will make you calculate the molar mass of that compound. And also, we are talking about the volume of CO2. So you figure out what is the volume of this CO2 in that equation. The mass of sodium carbonate will mean we calculate the molar mass. We will be given the atomic masses. So if you do that, the molar mass of sodium carbonate, which is Na2CO3, if you add it up together, that will be 23 plus another 23 plus 12 plus 16 times 3, that should give you 106 gram of the sodium carbonate. That should be the molar mass. And it's now giving us what's the volume of CO2 in that equation. It's not going to be 1. If you're thinking 1, that will be wrong. Remember, 1 means the number of moles of that gas in the equation. But for the volume, always have it in mind that 1 mole of any gas at STP is 20.4 dm cubed by volume. So since we have 1 mole of CO2 in that equation, then the corresponding volume will be 22.4 dm cubed. Had it been we have 2 moles of that gas, we have to multiply this volume by 2 of CO2. So with this, the problem is half solved. So you cross multiply, they are going to have 106 multiplied by x is giving us 3 multiplied by 22.4. Then from there, you are going to have your x be equals to 53 multiplied by 22.4 over 106. And that should give you, divided by 2, that will be 11.2 dm cube of CO2. For this, we are relating the question says, in that equation, baking soda is reacting with hydrochloric acid. Calculate the mass of baking soda that will produce 10 grams of CO2. The mass of CO2 is given 10 grams, so it's about the mass of this one. Then we have to calculate the mass of baking soda. This is the baking soda that's reacting with hydrochloric acid. So we're also talking about mass of this. So it's about mass of NaHCO3 with respect to the mass of CO2. So if that is the case, the question says, what is the mass of baking soda? So S gram of NaHCO3 that will produce 10 gram of CO2. So it's a mass-mass relationship. So that means we now go back to the equation and figure out the mass of NaHCO3 in that equation and the mass of CO2. So the molar mass of this one will be calculated. NaHCO3 molar mass will give you 23 plus 1 plus 12 plus 16 times 3. If you do this, your molar mass should give you 84 grams per mole. And the molar mass of CO2 in that equation will be 12 plus 16 times 2. And that should give us 44 grams per mole. So if that is it, we can now come back to what we have as expression here now. So therefore, the molar mass of NaHCO3, which is 84 grams, for 84 grams of the baking soda, the corresponding mass of CO2 is 44 grams. So with this now, we can cross multiply. Then we are going to have 44 multiplying the x, and then that will be equal to 84 multiplied by 10. So if that is done, we are going to have 84 times 10 over 44. And then our mass should give us 19.09 grams of NaHCO3. You can as well work around this, and instead of using mass of the CO2 that is given in the question, you can convert that to moles by saying mass over molar mass. So instead of 10 grams, you say the mass, which is 10 over molar mass, that will be 44. So instead of using the this mass A, you can change it to moles. But if you have changed this to moles, you are not going to use 44 gram A again for CO2. So in that case, you use the number of mole of CO2 in that equation, which is 1. So if you do that, you should get the same answer as what you have done here. This says you are given that equation, and the question says the volume of CO2 produced at STP when this mole of ethane was burnt in oxygen. So it's about the volume of CO2 that was produced when the 0.05 moles of ethane C2H4 was burnt. So volume of CO2 with respect to the amount or the moles of C2H4. So from the question given to us, we want to know X volume of CO2 that that's produced from 0.05 moles of C2H4. So once this has been done, you can go back to your equation and find out what is the volume of CO2 in that equation. This is CO2 in the equation, and you have 2 moles of CO2 there. The volume is not 2. The volume is going to be 2 multiplied by the standard volume. So that will be 2 times 22.4 dm cube of CO2 is what we have in the equation. And what's the amount of ethane in that equation? The amount is the number of moles. And you have just 1 mole there. So for 1 mole of C2H4. So with this, we can cross multiply. And then we are going to have x multiplying 1, x times 1 equals 0.05 multiplied by 2 multiplied by 22.4. And if that is done, we should have the volume to be equal to 2.24 dm cube of CO2 was produced from that reaction.